Picture yourself standing on a train platform right now. You look down, and there they are. Thousands upon thousands of gray, jagged stones, stretching as far as you can see in both directions. They're under the rails, between the wooden ties, piled up along the edges. And here's the crazy part, almost nobody stops to ask why they're there. Are they just leftover debris from construction, some kind of decoration, or do they actually do something important? Well, those simple stones, they're doing way more work than you'd ever imagine. What exactly are these stones? First things first, these rocks aren't random. They have a name. They're called track ballast. And they're actually one of the most critical parts of the entire railway system. Let me explain why. A typical freight train, it can weigh anywhere from 3,000 to 18,000 tons. That's the weight of up to 12,000 cars all concentrated onto two narrow steel rails. Without a proper foundation underneath, here's what would happen. The rails would sink straight into the ground like a hot knife through butter. They'd shift out of alignment with every train that passed, and eventually, they'd crack under all that pressure. The stones underneath prevent all of that, but what they're doing is actually more complex than just holding things up. To really understand why we need these stones, imagine for a second what would happen if we built tracks directly on dirt. Every time a heavy train rumbles past, the soil underneath compresses. The rails sink down maybe just a few millimeters at first, but millimeters add up fast. Before long, the track becomes uneven. Trains start to rattle and shake. You'd have to slow everything down for safety. And in the worst case, derailment. Here's something most people don't realize. Modern railways require extreme precision. For high-speed trains, track alignment can't be off by more than a few millimeters. That's about the thickness of two credit cards. So engineers needed something that could provide three things. Strength to support massive weight. Stability that won't shift over time. And maintainability, something you can adjust when needed. So what exactly do these stones do? They actually perform three distinct jobs simultaneously. Job number one, distributing weight. When a train rolls over the tracks, all that weight presses down on the rails. The ballast takes that concentrated force and spreads it outward. Instead of thousands of tons pushing straight down into soft ground, the pressure gets distributed across millions of individual stones, then gradually transferred to the earth below. It's like the difference between standing on someone's foot with a high heel versus a flat shoe. Same weight, totally different pressure. Job number two, water drainage. Water is actually one of the biggest enemies of railway tracks. If rainwater pools underneath the rails, the soil becomes saturated and soft. The whole foundation loses stability. Rails can shift, sink, or even wash out entirely. But because ballast stones are irregularly shaped with lots of gaps between them, water flows right through. It's like built-in drainage keeping the foundation dry and stable no matter how hard it rains. Job number three, locking everything in place. Here's where the design gets really clever. These stones have sharp, angular edges that interlock with each other, almost like puzzle pieces. Unlike smooth materials that would slide around, ballast creates friction. This does two things. First, it keeps the wooden or concrete ties from shifting sideways. Second, it maintains the precise spacing and alignment of the rails even when 10,000 tons of steel is thundering overhead. Think of it as a shock-absorbing, self-locking foundation that adjusts to loads but doesn't fall apart. Why not concrete or sand? At this point, you might be thinking, okay, but why not just pour a concrete slab? Wouldn't that be stronger? Great question. And yes, concrete is strong, but it has serious drawbacks. Concrete is extremely expensive to install over thousands of miles. If it cracks or settles, repairs are difficult and time-consuming. And without proper drainage systems built in, water can pool and cause even bigger problems. What about sand or dirt? Sand shifts too easily under heavy loads. Dirt retains water and becomes soft. Both compress over time, which means constant settling and alignment issues. Crushed stone ballast hits the sweet spot. It's strong but flexible, stable but adjustable when needed, relatively inexpensive compared to concrete, and incredibly easy to maintain. If a section becomes uneven, workers can literally just lift the rails, add or remove stones as needed, and re-level everything in a matter of hours. Try doing that with concrete. The shape matters more than you think. There's one more detail that makes all the difference, and most people never notice it. Have you ever looked closely at the stones? They're not smooth and rounded like river rocks. They're jagged, angular, sharp-edged, and that's completely intentional. If you use smooth, rounded stones, they'd roll against each other. Under the weight of a train, they'd shift and slide. The entire foundation would gradually fail. But crushed stones with sharp, irregular edges, they lock together. They resist movement. They create a stable, interlocking matrix. It's the same principle behind why gravel roads use crushed rock instead of smooth pebbles. The shape isn't just important, it's absolutely critical to making the whole system work. Maintenance never stops. Now here's something interesting. Even with all these advantages, train tracks don't stay perfect forever. Over time, the stones shift. Dirt and debris get mixed in, the track gradually settles out of alignment. So railway crews use specialized machines that do something called tamping. These machines lift the rails slightly, then vibrate the stones underneath, pushing them back into position and compacting everything into place. It restores the track to its proper alignment and keeps trains running smoothly at full speed. And this is exactly why ballast is so valuable. Maintenance like this would be exponentially harder and more expensive without those adjustable stones. So the next time you're standing on a railway platform, waiting for your train, take a moment to look down. Those rough, gray stones scattered beneath the rails might seem ordinary, even boring, but they're quietly performing three essential jobs: distributing thousands of tons of weight so the rails don't sink, draining water away to keep the foundation stable, and locking everything in perfect alignment even under extreme stress. Without them, modern rail travel would be slower, less reliable, and far more dangerous. It turns out the most ordinary details, like a pile of jagged rocks, are often the most important parts of the system.